So numbers in chemistry are really important. We use numbers a lot in different problems that we do, and especially experimentation. So you see two types of numbers, either something that's exact or a number that comes from a measurement. So an exact number or exact numbers are those numbers that you get from physically counting something or from a definition that is two units compared together in the same measuring system. And what that means is, like a really simple definition, let's see, what is something that we have heard before? Maybe this one, 100 centimeters equals 1 meter. So these are both a length measuring system, and it's a definition. So that's an exact number. Then if you were to buy a carton of eggs, and you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then you have 12 eggs. That is also an exact number. So exact numbers do not have a limited amount of significant figures. Now this term, make a little star next to it, because we're going to go back into that a little bit further throughout this chapter. They do not affect how many you have in a calculated answer, because an exact number is a definition, something exact. It doesn't have a limited number to it. Now measured numbers are the numbers that you get from measuring something. Height, weight, temperature, etc. This comes into play a lot when we're thinking of how precise you are or how accurate, especially when it comes to experimentation. So let's define first, before we look at this picture that I have here, accuracy. Accuracy tells you how close your measurement is to the actual value. So let's say that you are measuring the length of something or the mass of something, and you know what it's supposed to be, and you take some measurements. You then take the average, and how close that average is to what it's supposed to be tells you how accurate you are. Precision then tells you how close all of your measurements are to one another. So let's say you take 3 measurements. You have 5 grams, then you have 16 grams, and then you have 9 grams. And then on another trial, you have 4.5 grams, 5 grams, and 5.1 grams. What do you notice between these two sets of numbers that I threw out there? Well, in the first set, 5, 16, 9, there's a lot of variation in those numbers. In the second set, 4.5, 5, 5.1, it's not a lot of variation. Actually, they're fairly close to one another. So that's what precise is. You're looking at not even if you're close to what you wanted to get, but are your trials, your measurements that you're taking each time close to one another? Did you do the same procedure? Were you being really cautious? Did you get the same numbers? Now, applying that to these 3 pictures. In the first one, notice how you are accurate and precise. That's what it tells you that you are. Well, what does that exactly mean? Well, all 3 little dots are in the middle. So that means they reach the point they want, right? They're accurate in the fact that that's the end goal, and they're reaching the end goal. They're close to the actual value. And they're all close to one another, so they're both accurate and precise. Now in part B, notice how they're not even close to the center, the actual value, so they're not accurate, but the 3 trials themselves are pretty close together. So you can have measurements that you take that are very, very good and very close to one another, but not be accurate because you did not get the value that you wanted. Now in the third one, you're not accurate, you are not close to the actual value, and the trials are kind of all over the place, therefore you're not precise either. So inaccuracy in measurements is something that can be caused by determinate error, systematic error. And that's when the error occurs in the same direction each time. So it's always too high or always too low. It's the same kind of pattern. There's no discrepancy in the pattern. Imprecision, so if you're not precise in measurements, is caused by random error, indeterminate error. Measurements has an equal probability of being low or high. It occurs in estimating the value of the last digit of a measurement. So when you're taking a measurement And you have to guess kind of because a number, like if you weigh yourself, right? Or you're weighing something. And that last digit is kind of fumbling up and down and you're just not exactly sure what it is and you just kind of go with the number. That's when you're kind of being imprecise because you had to guess. So kind of putting that into play here. Look at the first picture on the left with the purple darts. Notice how the purple darts are kind of all over the place. That has large random error. Now let's review. What was random error? Random error was from imprecision, right? It kind of is equal probability of being too high or too low. There's no same direction of error. So because it's all over the place, we were being imprecise. It's random error because we didn't really have one direction. Now in the second picture with the pinkish red darts, notice how there's error there, but they're all close together. So you don't have a lot of random error because you're still pretty precise. There's not a high probability of being too high or too low. They're kind of in the same direction. They have a large systematic error, so you're inaccurate, but you're largely inaccurate, all in the same direction. Then if you look at the third picture with the green darts, you have small random error because, again, you're being really precise. They're pretty close together. There's not a range of different darts all over the place and no systematic error because you're basically accurate. So understanding measurements, a group of 3 students set out to determine mass of an object. The known mass is 10 grams. What do you notice about these measurements? So I want you to look at each 3 of these and kind of take a couple notes. Even maybe pause the video so you give yourself a good chunk of time to go over it. And whenever you take measurements, let's say 4 trials, 3 trials, the number that you're going to compare is the average. And just as a little review, the way that an average is calculated, it's the number of all trials, or I should say, sum of all trials divided by number of trials, which would be 4 in this case. So it's the sum of each divided by 4. And then that's the number that you compare. So student A, let's look. 10.49, 9.79, 9.92, 10.31. So that's kind of not very close. We have like a 10.5, 9.8, 10, 10.3, not precise. And the average, 10.13, is also not very close to 10, so not accurate either. Then we have 9.78, 9.82, 9.75, 9.8. So that's all around 9.8. That's actually, student B is very precise, or just precise you could say. And the average, 9.79 is 9.8, is not 10, so I'm going to say not accurate. Student C, 10.03, 9.99, 10.03, 9.98. So that all rounds to what? Basically 10, so precise for sure, very precise. And what about the average? Average is close to 10, so also accurate. So you can be precise and accurate, you could be just precise and not accurate, you could be neither, you could be accurate and not precise, just kind of depends on the errors that you have in your experimentation.